Good afternoon, Geometry Honor students. So Mr. Chen again. So today I would like to talk about day 3 lesson of A-3. So method of proving triangles similar. So the objective, use several method to prove that triangles are similar. So we'll talk about that angle, side. And the other one, it's the side method for proving triangles are similar. So let's start it off with the warm-up. The ratios of the height of triangle CDE to the height of similar triangle FGH is 3 to 5. So the perimeter of triangle FGH is 25 centimeter. So find the perimeter of triangle CDE. So as you can see, that triangle CDE will be smaller because that the given ratio for the height. So triangle CDE is smaller than the ratios of the heights of triangle FGH. So let's just set it up. So 3 over 5. So that equals the perimeter of triangle CDE. Since we don't know what that is, so let's say that's x. So x over the perimeter of triangle FGH, 25. So in order to solve for x, we can cross multiply. Another way you can do it is just finding the number to multiply straight across. So in order to go from 5 to 25, we multiply by 5. And then on top of it, you want to do the same thing. So 3 times 5, so that means x is what? 15. So the perimeter of triangle CDE, then that'll be 15 centimeters. So another one, given that triangle NPR is similar to triangle STV, so the measure of angle P, it's 90 degrees. Okay, so it shows that the perpendicularity symbol. The measure of angle R is 60 degrees. So this one looks like it's one of the special right triangle. So SV is 15. And then NR is 20. RP is 10. So you want to find out the measure of angle V up here. And then the measure of angle S, the base angle, and the measure of VT. So the way to do it, so you started with the matching, so congruent, similar triangles, so that means the angles got to be congruent, all three of them. So this one is also 60 degrees. And the base angle here, so the measure of this angle will be 30, because 90 minus 60, or 180 minus 90 minus 60, you get 30. So that means the measure of angle S, it's also 30. And then to get VT, so VT would be this one. So let's set up the proportionality. So VS over RN, so 15 over 20. It's the same as the ratios of VT over RP. So RP, which is what? 10. So this one cross multiply or perhaps reduce. So 15 over 20, so we got 4/5. 3 over divided by 5, so we got 3/4, so 3/4. So VT over 10, and then cross multiply, so we do have 30 equals 4 times VT divided by 4. So 30 divided by 4, it's not divisible, so just leave it as the way it is. Okay? So again, proportionality statement, so VS over RN, so 15 over 20, so which is the same as the ratio, so VT over 10. And then the rest of that, just cross multiply. Another thing that we can do here, you can just reduce, so VT, so that equals 15 over 2, which is what, 7.5 for VT. So now let's go over the theorem for that proving the similar triangle. So the first one is called the angle, and we can say that angle triple angles, because that once two pairs of angles are congruent of the similar triangles, so that means the triangles must be similar. So two pairs of angles are congruent, so that means the triangle got to be similar. And why is that? Because the third angle, we can use the third angle theorem to figure out that the third pair of angle got to be congruent as well. So this one, if you see that angle A is congruent to angle D, angle B is congruent to angle E. So therefore, triangles ABC is similar to triangle DEF. Okay, so using that angle theorem to prove that triangles BFE is similar to triangle CFD. Okay, so BFE, this triangle here, is similar to CDF. Okay, so CDF. Okay, those two triangles. So one thing that we notice, so ABCD is a parallelogram. Well, if ABCD is a parallelogram, so we can start it off with the given. So using the properties of a parallelogram, we do notice that angle CDF instead of saying that CDF, we can say that angle C is congruent to angle CBE. And the reason for this one is called the alternate interior angle. Again, started with the parallel lines first, because that DC, segment DC is parallel to segment AE. So segment DC is parallel to segment AB. And the reason for this one is because the property of a parallelogram. And the other one that you want to stay here is that angle C is congruent to angle CBE. If two lines are parallel, that means the alternate interior angle got to be congruent, alternate interior angle. And then statement number 4, you can say that angle DFC is congruent to angle BFE or EFB. Definition of vertical angle. And then statement number 5, just state that triangles BFE is similar to triangle CFD, angle. Because one thing that we show that the angle here, those are congruent angle, and also the vertical angle, they're congruent as well. So therefore, by using angle theorem, so we can state those two triangles are similar. Okay, so here's another one. So SP is the altitude. So where's SP right here? So SP is the altitude from S to NR. If this one is the altitude, that means the height of the triangle, it's always perpendicular to the base. And also the other side length right here, RT, another altitude to the triangle. We talked about altitude before. So once we get the point of intersections of the altitude, so there's a name for that. Is that the circumcenter? Okay, so now, and we want to show that triangle NRT. Okay, so NRT. Okay, so this triangle here, NRT, it's similar to triangle NPS, okay, the overlapping triangle. So one thing that we want to say here, so is that the using that angle, okay, so let's say angle N is congruent to angle N. Okay, so normally we started with the given. Yeah, just start with the given first. So SP, RT, you know, all that, the height of the triangle. So those are the heights of the triangle. So one thing that we notice is the perpendicularity, the right angle. Okay, so we can say that angle NTR equals 90 degree. Same thing happened with angle SPN equals 90 degree. So this one is called the definition of an altitude of a triangle. So anytime they see the altitude of a triangle, so it's always perpendicular. So this one, therefore, NTR is congruent to angle SPN. Okay, so definition of congruent angles. Another thing is that angle N is congruent to angle N. reflexive properties of equality. And therefore, triangles NRT is similar to triangle NSP by angle. So here's another theorem, side. If there exists a corresponding between the vertices of two triangles such that the ratios of the measures of the corresponding sides are equal. So you see that the proportionality statement that we wrote for the previous sections. So if this one happens, if they're all equal, so therefore the triangles are similar. So triangles A, B, C is similar to triangle D, E, F. So AB, okay, so the versus DE. I don't want to use the tick mark. If that's tick mark, that means you're congruent, so I'll use the little circle. And then the other one, BC to EF, and then AC to DF. Okay? So explain why the triangle below are similar. So compare the base, so 9 versus 2, so 9 over 2, and then the side length. So this one is 6 over 3, and the other one is 9 over 3. Well, obviously they're not equal, okay, so therefore these two triangles, they're not similar. And then the third theorem to prove that the triangle is similar is by using psi, angle psi. If there exists a correspondence between the vertices of two triangles such that the ratios of the measure of two pairs of corresponding sides are equal, and the included angles are congruent, so like this one here, so then the triangles are similar. So AB compared to DE, and then BC comparing to EF, and then the included angle B and E, those are congruent angles. So if this one is the case, so that means triangle ABC is similar to triangle DEF. So explain why the triangle below are similar. Because this one, the ratio, we got 4 over 1, which is the same as the other ratios, 12 over 3, so it's all 4, common ratio. And also the included angle in between those proportionality segments, those angles are congruent, so therefore these triangles are similar. So here's the practice problem. State whether each pair of the triangles is similar by angle similarity, side similarity, side angle side. If none of this apply, write and. So check this out. So 7.5 over 12, comparison, proportionality. And then the other one is 5 over 8. So 7.5 over 12 is like 75 over 120. And then reduce, divided by 5, top and the bottom. So this one will get 15. And this one divided by 5, so then we'll get 24. So 15 over 24 divided by 3, so we got 5. This one we got 8, so 5 over 8. It's the same ratio, so common ratio, 5 over 8. With the included angle, so yes. So this triangle, they're similar by using psi, angle psi. And what about this one? This one is 28. Over here is 125. The third angle, would that be 27? Let's find out. 180 minus 28 minus 125. Subtract the bigger number first. So 180 minus 125, then we'll get 55. Minus 28. 15 minus 8, that's 7. 4 minus 2, 27. It is 27 degrees. So by using angle, so triangles are similar. And this one right here, common ratios. So let's get the common ratios. So the longest leg, so it looks like what, 42 compared to the other triangle, the longest leg, 21. Would that be the same ratios as the other one? So the medium leg, so 22 over 20. Okay, let's find out. 40 over 21, it's not reducible, which is not the same as 22 over 20, because this one is 11 over 10. So obviously they're not equal. So triangles are not similar. So just write down none or n. And what about this one here, triangles? So this one, two sides are congruent. The other two sides are congruent. So they share the same diagonal. Well, this one, besides showing the triangles is similar, but also they're congruent. Anytime that you see the congruent triangle, so that means the triangle they're similar as well. Okay, so this one, yes. And the way to do it is by using side, side, side. Proportionality. And then the rest of the practice problem, they're quite similar to what we're doing. Either you need to find out the missing variable or three sides are given. So you want to set up the proportionality statement, compare the ratios, make sure that they all share with the common ratio. If the common ratio does not exist, so that means the triangles are not similar. Okay, so now let's see what else that we have. So this one is just a summary with what we're doing. Angle theorem, side, 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 angle, side. Okay, so here's one of the particular problems, similar to what we did, proving that triangles KHJ is similar to triangles HGJ. Okay, so it's quite similar to the problem that we did earlier. Exit ticket, so M is the midpoint of JK, and N is the midpoint of KL. Well, N is the midpoint of KL, and then P is the midpoint of JL. So this one is the mid-segments of a triangle. So which method can be used to show that triangle JKL it's similar, must be similar to triangles N and P. Okay, so if that's the case, so this one is the mid-segments, this one is the base. So if that's the mid-segments, so that means it's always parallel to the base. Okay, if those two line segments are parallel, so that means the corresponding angles must be congruent. Okay, so this two angle right here got to be congruent. Okay, let's put it this way. So that angle NMP must be congruent to angle K. Another thing that we notice, so this triangle versus the big triangle, and since we do know that those two angles are congruent, anything that they share in common. Okay, so what about so angle N, angle J. Okay, so those two angles gotta be congruent as well. So this one we're using angle theorem. And other things that's showing it's the midpoint. So angle N, angle J, we're not quite sure whether that they're congruent or not. So another thing that we can state is that the segment, so M is the midpoint, so that means this one, the segment, MJ, gotta be congruent to KM. JP is also congruent to PL. Okay, but the thing is that the mid-segment has nothing to do with the small triangle here, NPM. So it's better to use that angle. Okay, so angle, so there's two angles, and also the vertices, the vertex angle. Okay, so now, thank you for watching the video today. So about those three different theorem, angle, side, angle, side, side, with the proportionality to prove the similar triangles. Okay, so I'll see you guys next time.